I'm going to talk about a little bit about the gamification, the role in planning and urban design. My name is Kushan. I'm an urban planner and an architect. And much like any millennial in the room, I tend to get bored pretty fast with data and everything. So I want to keep it very sort of scenario planning-y, very sort of game boardy at the same time. So what I'm going to talk about is sort of this touch upon a few basic concepts of gamification. What does that mean? We're going to look at some project examples where we have used game boards to sort of solve real urban planning and design challenges, and then sort of kind of transition into what were some of the challenges that we faced, what are some of the limitations that we face from a geodesign perspective and from a digital game board perspective. So before I start this, I wanted to nerd for a little while. Any sort of Office fans in the room? Great, wonderful. So for those of you who don't know Office, paper salesman guys trying to sell as much paper as they want, right? So Dwight Schrute is playing this game. The guy on the right, oops, I should probably use this. This guy on the right, he's playing this game called Second Life, and he's trying to figure out, and he's so much into it. He's totally intense playing the game. And Jim asks him, "What are you doing?" And he says, "I'm playing a game." So he frowns, and then Dwight goes on to add, well, it's not a game, it's a real-time virtual environment. But what Dwight was trying to do is he was trying to answer a very critical question through this game. How can I sell more paper? Now, as much as I like Dwight, to be honest, the solution was ridiculous. His game was in where, and I quote, absolutely everything was the same except I could fly. So his solution to selling more papers was to create a game where he could fly. So, which begs us to ask this question, what does this mean? What is gamification? So the traditional definition is motivating users to achieve their goals that are often at odds with each other. And by better understanding the trade-offs as we play these games, that create conflicted opinions so that users can find common ground. And games have been used to solve real-world problems, right? For example, Folded Gamers in 2012, they solved AIDS, there was an AIDS puzzle and gamers used it, and they kind of advanced the research on AIDS. StarCraft game was used and is currently being used by military officials to train their staff in leadership qualities. So what is the motivation? Well, much like our friend Dwight, we are talking about abstraction of reality and interfacing with that version of reality. Now, SimCity 1998, probably one of my favorite games growing up. What it did was it rewarded behavior, it rewarded positive behavior. And as we sort of co-create a version of reality, our brains are wired towards creating something where we are rewarded higher points. And at the same time, we are also iterating and simulating time. And the most important part, which I've learned through my practice, is this idea of role-playing, which allows to absorb vast amounts of information, especially with private stakeholders, public stakeholders, citizens. They can absorb vast amount of scientific data when they have assigned specific roles in a sort of a game scenario role. So what does this mean for planning, right? As urban designers and planners, we are wired to learn from the past. This is Flint in 1965. Notice all the density sort of in the core downtown area right here, and sort of the developments along the street. And we want to understand the present. Notice how all of that has given away to big parking lots, and how there is a sort of a new highway that cuts across communities and causes social disparities. And we want to understand all this in the context and sort of create theoretical models that can help us optimize the future. And so what in theory we are trying to do is we are trying to answer these basic questions for planning. We're trying to answer which intervention or scenario or a plan is a better plan that satisfies cities' goals or objectives, which is more sustainable, resilient, what are the gaps, how can we measure and quantify the cost of sustainability, and so forth. And we've been doing this for a while, right? We have created analog boards. We have created sort of these be it block models, be it sort of combination of block and CAD and Excel models, and these digital sort of analog models help us create two basic kinds of scenarios. Kind of what I call the baseline scenario or the trend-based scenario, which is what will happen. Then there are normative scenarios, which is sort of an end state scenario. How can we reach a particular target? But that doesn't really leave a lot of room for exploration. And as sort of an urban designer, I love that idea that you can quickly do something, test it out, and explore what's happening in the real world. And this is where sort of the digital game boards come really in handy. The idea that you can you're not wired towards what will happen or what is the end state that you're trying to reach at, you're just testing out ideas or what can happen. And the second idea where I kind of feel that digital boards are really helpful is this idea of sort of tying across scales. You can have something sort of at the local scale, and this was a project we did in Chicago, sort of net zero streets, where we are looking at what were the sort of the place type interventions, where can we locate geothermal fields, where can we locate sort of solar panels to create sort of energy that can be distributed across the grid. How can that be used to incentivize zoning in certain parts of these sort of carbon neutral hubs? At the neighborhood scale, you can take all of that, sort of all of those net zero communities, net zero type, and sort of tie it with it, the TOD and MOD zone. You can further sort of go on translate all of that at the city scale. So you can start to look at TOD, MOD, carbon emissions, and translate that into a concept of livable city. This is what we did in Santa Marta in Colombia. And sort of, again, take that scale, take the city scale, take the neighborhood scale, take the local scale, and boil it down all the way to the region where we are trying to make sort of a sustainable infrastructure, make a sustainable region, which speaks to all the scales of planning and urban design. So there are tools out there right now. A lot of you might be using GeoDesign Hub, City Engine, you might be using Urban Footprint, Tigron, and whatnot. There are many tools out there. But what's exciting to me is the idea that you can attach your models with the GeoDesign tools. So we have, over the course of time, we have what I call calculators. That's what we have developed over the time. And we attach that to our geodesign process. So for example, there are urban design calculators, there are wastewater calculators, mobility, waste management, and all of these sort of run simultaneously along with the geodesign tools. And this is just an example of how those sort of models work, or sort of the sub-models within those sort of the broader models that you saw. This is sort of a district energy modeling tool right here, and the building energy modeling tool, which is nested under the energy, and how we can sort of use that, optimize that, set priorities according to the plans and objectives that we are trying to achieve. And this is an example of, again, Flint, Michigan, what you saw earlier. And I'm going to play a little video, and I'm going to talk through it. But the idea here was that we were trying to stimulate economic development and activate the market. And how can we use digital game boards to do that? Have these data models attached to these sort of 3D shapefile and object data. Hopefully it works, and it does. So we have these 3D objects with shapefile attribute data. So we have parking, how much parking is available throughout the time of the day. We have not just sort of the big parking lots, but also on-street parking, what is the capacity. We also have parking lots, how much is available, is it public, private. We also have building data associated with it. So we model in vacancy, where is the vacancy, is it ground floor, upper floor, what kind of vacancy, how much square feet, what can we do where, so that it activates the street at a broader level. And then again, there's this idea of sort of dashboards to measure demand and supply. How much are you creating? What is sort of as you create your scenarios, how much are you creating? How much are you meeting the demand? How much are you meeting the supply, generating new supply, and so forth. And these were sort of quick place type definitions that we used to sort of calculate these geodesign models and come up with these calculators. And I'll get into the place type aspects a little bit later. And this was sort of our community engagement process. So geodesign isn't super easy for everybody to use. So what we did was kind of an in-between method where people were drawing on the game board, or sort of the physical game board, and I was there translating that into a digital or sort of virtual environment. And what it helped was that people could look back at the screen and see how much they did, and then kind of optimize their decisions going into the next round. And this was done sort of in a variety of settings, not just sort of an open public setting. People could come in, leave whenever they wanted, give us inputs. And what this really helped was that over a course of day and a half, we ended up creating about 6 scenarios. And we took these scenarios, went back to our drawing boards, and we had sort of more objective inputs that we can then form our planning and policy decisions on. And I'm not going to get into too much detail of this, but this was sort of this is a project we did with C40 cities, where we are trying to understand the impacts of land use on freight demand and CO2 emissions. So for example, a commercial land use will attract certain kind of freight, and during the time of the day, what does that mean given your on-street and off-street parking regulations? Do you have loading berths, for example? And therefore, what is the likelihood of that truck idling around the neighborhood and creating or contributing to the emissions? So this goes on for a minute, but I'm going to skip in the interest of time because the next video is more interesting. And this one looks at sort of a more complicated model where we have managed to attach our geodesign sort of module with our analytical modules. And the trick here was to have an easy UI or easy user interface where we could sort of click and then apply these different place types, taking it from our place type library, be it buildings, open streets, sort of coastal protection, so we can sort of look at resiliency, for example, and that generates a scorecard. We can also create different scenarios. We can load pre-built scenarios, and we can start to build on top of those pre-built scenarios. And at the end of the day, we can compare these scenarios for decision making. So what this process really helped us do was we ended up creating about 20 to 25 different scenarios, and we could see a common thread of what can be, and then again, sort of from that, had our final plan that we derived. And this is something that is still in works, but I thought it would be interesting to share anyways. This is a probability allocation model that we are currently doing in Houston. This is complicated in the sense that it ties a lot of transportation demand modeling and transportation networks with the land use. And as many of you who kind of work in that field can realize that it's not easy. It takes a lot of time to run these kind of simulations. So in that sense, it's not real time. And I'll get to the process of how we have done that in a bit. But the idea here was that we take the existing land use, we create these probability surface on a lot of sort of attractors and detractors that was based on research, and then we take our place type allocation module, and then the score that's generated, it picks up about 3 to 4 different place types and allocates to a certain grid. And that's how we create, again, a series of scenarios, and from there we kind of take a final approach. So what you just saw is kind of this is kind of a very basic, these are the basic components of what you just kind of saw of making these digital game boards. We have our parametric urban design rules, which we use to sort of optimize things. And then we have advanced impact analytics that takes data from this whole process and then comes up with a set of indicators. Again, these indicators are not set in stone. They need to be contextualized in the sense that you need to look at New York City is different than DC is different than sort of Florida. So we have to look at these indicators in the context of that. So these models give us the ability to tweak or sort of fine-tune each of those indicators. So some of the components of creating these digital game boards. Number one is place types. I think some of you have already talked about it yesterday. The idea of sort of place types, it could constitute one building type or different building types. So what we have is sort of a library of about 250 plus building place types, which pulls in data from the building type models that we have. And these building types are different for different contexts, right? So for example, for New York City, the building types will be very different. So when we choose this model, the place type kind of knows what we are getting or we are fetching data from. And then there is sort of the street definition. There is the idea of width and function, which changes with street types, and how that street type relates with the land use. So for example, certain regional arterial corridors have different kind of land uses that are around that, versus a neighborhood collector, they have different kind of land uses around that. So the idea really was to try and at least have that interface between street type and land use. It's not getting too much into the heavy transportation data sets. And the third and the most important part are calculators. Right now, we create a lot of calculators using CGA, but as you can imagine, those are sort of rudimentary at this point. So we need sort of custom calculators. The custom calculators and the CGA calculators help us create these dashboards. And these dashboards, in my opinion, have been super important because they help, again, comprehend the complexity of data analytics that run behind it. So as a user who doesn't know data, who doesn't know urban design, you can understand what were the impacts of the design decisions that you took on your digital game board. And then we get into sort of the last part of the presentation. I think I'm going pretty fast. Getting the last part of the presentation, where we are looking at integration with complex data sets. Now, this is a real challenge. Like I mentioned, we have been working with transportation engineers, we have been working with transportation planners, and they have these complicated data sets, transportation demand models, transportation network models, and it's really hard to integrate that with land use. We came up with the process, but as you can see right here, about in the center of the screen, the model output still takes about 2 to 6 days to run, right? And that's not real time. But this is assuming that we are running this on an 8-core system. Now, if you had 64-core systems running parallelly, maybe you could do it in an hour. This is certainly a challenge when we are trying to simulate or create digital game boards with meaningful impacts. The second sort of the challenge that we face are non-space-based components. Like, how can we measure planning strategies that do not have spatially explicit outcomes? For example, parking policies or congestion pricing. How can we get those things into digital game boards? What are the models that can help us get there? And the last part is sort of this idea of augmented sort of, or what I call sort of intelligence augmentation, not the AI, but the IA. That eventually, AI might take over sort of the mundane task of planning and urban design, but the idea that you can interact with AI in a meaningful way and then sort of create these meaningful insights, identify hotspots, and then get into your digital or sort of your drawing boards to create scenarios is something which I think, based on my professional practice so far, is something that I think is more likelihood outcome of this process. So with that, and I think I've saved you some time, but I'm just going to say thank you, and then let's play.